something moves at the edge of your vision, low, fast, near your foot. Before you've had a single conscious thought about what it is, you've already jumped back. Your heart rate has already spiked. Your body has already acted. Then, half a second later, the actual thought arrives. It was a hose, or a shadow, or nothing at all. Here's the part worth sitting with. Your body didn't wait for that thought. It reacted first, and the explanation showed up after, almost like your mind was catching up to something your nervous system had already decided. That's not a coincidence, and it's not you being jumpy. There is a specific, separate pathway in your brain built to do exactly that. React before you understand what you're reacting to. This should be strange if you think about it directly. You'd assume fear works like most experience does. Something happens, you perceive it, you interpret it, and then you feel something in response, in that order. Perception first, feeling second. But a flinch like that doesn't wait for interpretation. The jump happens before you know what you jumped at. That means somewhere in your brain, a threat can be flagged and acted on before the part of you that actually understands what a threat is has even weighed in. So the real question is, what part of the brain is fast enough to do that? And how does it manage to act on a threat it hasn't actually identified yet? Neuroscientist Joseph LeDoux spent the late 1980s and 1990s tracing this exact question through a series of experiments, mostly using rats. His method was a version of classical conditioning, the same basic idea as Pavlov's dogs, but built to map brain circuitry instead of digestion. A rat would hear a neutral tone, then immediately receive a mild shock. After enough repetitions, the tone alone, no shock at all, was enough to make the rat freeze in fear. That gave LeDoux a clean, repeatable fear response he could trace backward through the brain, structure by structure, to find out exactly which path the signal was taking. In a series of papers published between 1988 and 1990, LeDoux and his colleagues found something nobody expected. There wasn't just one route carrying that threat signal to the amygdala, the almond-shaped structure at the center of the brain's fear response. There were two, and they didn't arrive at the same time. LeDoux named these two routes the low road and the high road in his 1996 book, The Emotional Brain, and the names describe exactly what each one does. The low road runs directly from the thalamus, a kind of sensory relay station deep in the brain, straight to the amygdala, without ever passing through the cortex at all. That's the part of the brain responsible for detailed, conscious processing. Skipping it is exactly what makes the low road so fast. It's also what makes it crude. The low road isn't capable of fine detail. It can't tell a snake from a hose. What it can do is notice long, thin, coiled shape on the ground, and fire a fear response immediately, before any of the details get sorted out. LeDoux himself used almost that exact example. The low road sees a shape that might be a snake and reacts, while a separate, slower pathway is still working out that it's actually just a garden hose. The high road is that second pathway, thalamus to sensory cortex, where the detail actually gets processed, and only then to the amygdala. It's slower. It's also the reason you eventually realize you jumped at nothing. By LeDoux's own account, becoming consciously aware of a stimulus at all takes somewhere around 250 to 300 milliseconds. The low road doesn't wait for that. It's already triggered a reaction in your body before the conscious part of your mind has even finished registering that something happened. LeDoux's model was built entirely on rats, which raises an obvious question. Does any of this actually hold up in a human brain? In 1998, a team led by researcher Paul Whalen at Massachusetts General Hospital ran the human test directly. Using fMRI, they showed participants a fearful or a happy face for just 33 milliseconds, immediately covered by a neutral face for another 167 milliseconds, a technique called backward masking, fast enough that the emotional face never reaches conscious perception at all. Afterward, 8 of the 10 participants reported seeing nothing but neutral faces the entire time. They had no idea an emotional expression had ever appeared. But their amygdalas knew. Brain activity was measurably higher when the hidden face was fearful than when it was happy, even though the conscious mind never got the memo. An even more extreme case makes the same point more directly. Researcher Beatrice de Gelder studied a patient known as GY, whose visual cortex, the high road's own destination, the part of the brain responsible for actually seeing anything, had been almost completely destroyed by a stroke. By every clinical measure, GY was blind in the affected part of his visual field. He could not consciously see a face there at all. And yet, when researchers showed fearful and happy expressions to that blind region and simply asked him to guess which one it was, he guessed correctly far more often than chance would allow, and his amygdala lit up specifically for the fearful ones. Neuroscientists call this affective blind sight, a threat signal reaching the amygdala through a completely separate route that never touches the cortex at all, exactly the shortcut LeDoux's low road describes, demonstrated in a human being who, by his own conscious experience, saw nothing whatsoever. Neither Whalen's masked faces nor de Gelder's blind patient needed a hose in the grass to prove the point. But it is the same mechanism that made you jump back before you had worked out what you were looking at. Researchers think GY's intact pathway runs through much older structures, the superior colliculus and the pulvinar, deep in the midbrain and thalamus. The same kind of ancient, cortex-free shortcut LeDoux mapped in rats, just confirmed here in a human brain that had lost the ability to consciously see at all. The cortex is optional. The amygdala was never waiting for it. It's worth being precise here about what this circuitry actually explains, because LeDoux's own thinking on this shifted significantly over his career, and the later version matters. For years, the low road was often described, including by LeDoux himself early on, as essentially the source of the feeling of fear. Find the amygdala circuit, and you found where fear itself lives. In his later work, particularly in his 2015 book Anxious, LeDoux pushed back hard on that idea, including his own earlier framing of it. He drew a sharp line between two things that had often been treated as the same: the unconscious defensive circuit, the fast, automatic jump-back reflex, and the conscious, subjective feeling of being afraid. Those are not the same event measured two different ways. They're genuinely different phenomena. A rat can have its defensive freezing circuit fully intact and functioning, with no way to know whether the rat is having anything resembling a subjective experience of dread at all. The low road explains the flinch. It does not, on its own, explain the feeling that shows up after it. That distinction isn't just academic housekeeping. It's the reason exposure therapy works the way it does. Treatment aimed at retraining these circuits targets the fast defensive response specifically, not simply trying to talk someone out of a feeling. So why do you flinch before you consciously notice the danger? Because your brain built a shortcut specifically so it wouldn't have to wait for you. The low road doesn't need your understanding, your attention, or your permission. It only needs a rough shape and half a chance that the rough shape might be dangerous. The jump isn't a malfunction, and it isn't you being dramatic about a hose. It's a several 100-million-year-old bet that being wrong fast is safer than being right slow. By the time you figured out what you were afraid of, your body already made the only decision that actually mattered in time. That decision was never really yours to make. It just happened to be made inside you. You didn't choose most of what makes you what you are, but you can choose to understand it. New mechanism, always sourced every week. Subscribe if you want to keep finding out what's actually making you tick.